Hi guys, so we are going to look at this paper. This is Science Paper 2, 2022 GCE. So we're going to start with Section A. First question, the branch of chemistry that deals with the identification of composition of substances is, so the branch of chemistry that deals with the identification of composition of substances is, now this branch of chemistry is called analytical chemistry. That is the answer. Second question, the following diagrams show the arrangement of particles in a substance under normal atmospheric pressure but at two different temperatures. So we have one which is at 125 degrees Celsius negative, the other one is negative 90 degrees Celsius. Then which substance could the diagrams represent? Now let's look at that. We've been given melting point in degrees Celsius and boiling point in degrees Celsius. So in order for you to melt, of course this here is a solid because of the arrangement of particles, then this is a gas. So in order for you to melt this solid, you would need a temperature that is higher than negative 125, and so the melting point here from the answer choices, the answer can either be C or D, because C and D are the only choices that are showing a melting point that is higher than negative 125. Then the boiling point, we have negative 88 and negative 92. So now the boiling point, in order for this to be turned into a gas, we need a temperature that is a bit higher than negative 90 degrees, because we are looking at this. So this is so we want something less than negative 90 degrees. So when we are looking at temperature now for a gas in terms of boiling, we need a temperature that is lesser than negative 90 degrees, and the temperature that is lesser than negative 90 degrees is negative 92. So the correct answer for the second one is answer choice D. Answer choice D is the correct answer. We proceed to A3. The following diagram shows part of a laboratory thermometer. What is the temperature shown in degrees Celsius? So now look at, this is 20, there's a 2 and a 0 here. So then this is 33 0. So we're just looking at that. So that is the measurement we're looking for. So if we check there, this is 20, then that is 30. If we go downwards, this will be 29, then this will be 28. So the reading there is actually 28 degrees Celsius. So the answer is answer choice C, 28 degrees Celsius. Number 4, the following table lists the data obtained in a titration experiment. Which reading should not be included to compute the average volume of the acid used in the titration? So the one which should not be included here is the one that is not close to the rest. If you check, we have 12.9, we have 13.0, we've got 12.8, we've got 11.9. Now 11.9 is the only value that is far away from these other values. A, B and C are close, but 11.9 is far away from those values. So the answer choice for number 4 is answer choice D. F5, the following diagram shows a chromatogram obtained when sample V was analyzed together with 4 other known dyes W, X, Y, Z. Dye X was known to be poisonous. Which of the following dyes are safe for use? Now, we are saying dye X is poisonous, so it means all these other dyes that go in the same line as X all these are also poisonous. All these are also poisonous. So the only one which is safe for use is Z, because Z has not traveled, does not contain X. So Z is the only dye that does not contain X. So the answer choice for number 5 should be D. So Z only. A6. The following diagram shows the structure of an atom. Okay, what is the proton number and nucleon number of the atom? Now, proton number in an atom, this is we're just looking at the number of protons in the nucleus of an atom. That is proton number. So how many protons are there? So now there is one. We look at the p's. 1, 2, 3. So there are 3 p's, so meaning there are 3 protons. So the number of protons are 3. So number of protons are equal to 3. Then what of the nucleon number? The nucleon number is also referred to as the mass number. So the nucleon number is also referred to as the mass number. So the mass number is the total number of protons and neutrons. So you count everything in the nucleus. We have 1, 2, 3, 4, 5, 6, 7. So we have 7. So we should find 3 and 7. So which one is giving us 3 and 7? That is answer choice B. So 3 protons and the nucleon number of 7. We proceed to look at question. Alright, question 7. Lithium occurs as a mix of 2 stable isotopes, lithium 7.5 and lithium 92.5%. The relative atomic mass of lithium is, now if you are to find the relative atomic mass from percentages, this is what you do. So we've been given percentages, so we've been given 7.5%. To get rid of the percentage, you divide by 100, multiplied by its mass. The mass is the one on top. The mass is 6. Now this, we add it to the other percentage, which is 92.5. We divide by 100, so the percentage is gone, multiplied by the mass is 7. So these are isotopes. So once you do that, what do you get? So you get your calculator, then you do those calculations. 7.6 divide by 100, then the answer you multiply 6, then you say plus what we have there. We've got 92.5 divide by, okay, so 92.5 divided by 100, then multiplied by 7. So 92.5 divided by 100, right, then multiplied by 7. I'll do that. Okay, so on that one, so let me just so you use brackets. Ensure that you use brackets so that you don't make mistakes. So we have that, so multiplied by that, close brackets, then you are now adding, you say plus, open brackets again, 92.5 divided by 100, then you are multiplying by 7. Then what are we getting? So I'm getting 6.925, getting about 6.925 to 1 decimal place, because all the answer choices have got 1 decimal place. It will be 6.9. So answer choice C is the correct answer for number 7. Right, then we proceed to number A8. Magnesium forms magnesium 2+ ions. The number of electrons in a magnesium ion is, now look at magnesium. Basically magnesium has got 12 electrons. Now if we say magnesium 2+, a plus means it has lost 2 electrons. So you just say 12 minus 2 electrons, we get 10. So the number of electrons are 10 electrons since it has lost 2. Number 9, which element exists as monoatomic molecules at room temperature and pressure? So the elements that exist as monoatomic at room temperature and pressure are all noble gases. So we have helium, argon, and neon. So that is answer choice A. Number 9 is answer choice A. Okay, number 10, deduce the formula of lead 2 phosphate. Lead is Pb, then phosphate is PO4. To deduce the formula, you need to understand the valence. The valence of lead 2 is 2, the valence of phosphate is 3. Then these are going to swap. So I'm going to say Pb, the 3 is going to come where valence is. Then PO4, the 2 will go where lead is. So Pb3, PO4, 2. So on number 10, the answer should be C. Alright, we go to question 11. Which one of the following substances dissolves in water to form a solution with a pH of less than 7? Now, a solution with a pH of less than 7, that is an acidic solution. And from the answer choices, the only one which can form an acidic solution when dissolved in water is sulfur dioxide. It's actually the one that causes acid rain. So sulfur dioxide. Right. So that was question 1. So question 8 has been dealt with, question 9 has been dealt with, question 10 has been dealt with, question 11, question 12. Dilute sulfuric acid reacts with both magnesium oxide and magnesium carbonate. How are these two reactions alike? So now, whenever an acid reacts with magnesium oxide and an acid reacts with magnesium carbonate, they are alike in such a way that in both water will be produced. So water will be produced in both. So when an acid reacts with a base, water is produced, and when it reacts with a metal carbonate, water is equally produced as well. Of course, there are other products, but water is one of them. Question 13. Crystals of sodium carbonate decahydrate are efflorescent. When these crystals are exposed to air, the crystals, so an efflorescent substance is a substance that is going to lose its water of crystallization when exposed to the atmosphere. So now what will happen here is when water of crystallization has been lost, it means there will be a loss in mass, but it will still remain a solid. There will be a loss in mass, but it will still remain a solid. So meaning the answer choice C is the correct answer on number 13. We go to question 14. 1 mole of nitrogen and 1 mole of ammonia gases have. So now 1 mole of nitrogen and 1 mole of ammonia, they've got equal number of molecules. These have got equal number of molecules. Now look at nitrogen exists as a diatomic and ammonia is NH3. So 1 mole of this and 1 mole of that. So if there is 1 mole of nitrogen and 1 mole of ammonia, they've got equal number of molecules. Here, this is 1 molecule of nitrogen, 1 molecule of ammonia, but they've got different number of atoms. Alright. Question 15. A solution of calcium chloride contains 11.1 grams of the salt in 250 cubic centimeters of the solution. What is the concentration of the solution in moles per cubic decimeters? How do we find concentration? Concentration is the same as molarity. Concentration is given by number of moles over volume. Now the volume, we've been given 250 cubic centimeters. Then the number of moles we've not been given, so we can say number of moles is equal to mass divided by the molar mass. The mass given is 11.1. Then what is the molar mass of calcium chloride? So you just have to write calcium chloride like that. Now what is what we have is this, so calcium chloride. So the question is that what is the molar mass of calcium chloride? So we start, chlorine is 35.5 multiplied by 2 atoms, calcium is 40 multiplied by 1. So 35.5 multiplied by 2 atoms, so that one is going to give us 71. So this will give us 71, then we are adding with 40, which will give us 111. So we'll get about 111 grams per mole. So that is the molar mass. So 111 grams per mole. Then the mass is in grams. The grams are going to go. We only remain with the mole. So when you say 11.1 divided by 111, you get 0.1 as a number of moles. So 0.1, so you're going to say number of moles is 0.1, then divided by the volume is 250, then you divide it by 1000 so that it becomes in decimeters cubic. Then you just punch those on a calculator. So I'm going to say 0.1, then I'll divide by, I open bracket so that I start by saying 250 divide by 1000, then I close brackets. So I'm finding my answer to be 0.4 moles per decimeters cubic. So 0.4 moles per decimeters cubic. So the answer choice here, answer choice C is correct. Question 16. When an excess of magnesium powder was reacted with dilute hydrochloric acid, the reaction was fast at first but gradually became slower and finally stopped. Which of the following best explains why this happened? So now we are saying when an excess of magnesium powder was reacted with dilute hydrochloric acid, the reaction was fast at first but became slower and finally stopped. So in here, the acid was being used up. So the answer choice A is correct. So the best reason is that the hydrochloric acid was being used up. Because why? Because we are putting in an excess amount of magnesium powder. So every time you put in magnesium powder, the acid is going to be used up. Right? So we look at question 17. What could be the chemical formula of the nitrate of an element Q of group 3 of the periodic table? So here they are simply saying you have an element Q. If it is in group 3, so it has a valence of 3 with a nitrate. What is the valence of nitrate? The valence of nitrate is 1. These are going to swap. We're going to say Q, then NO3, then we put a 3 there. So this is the chemical formula. So the answer choice D is correct on number 17. Number 18, some metal ores are roasted in air before they are reduced in the blast furnace. What is the main air pollution caused by this process? So the main air pollution that is caused by the process of the blast furnace is that the main air pollution is the sulfur dioxide. So sulfur dioxide. Okay, we look at 19. 19, okay, 19 and 20 we have organic. There are questions on organic chemistry. So now let's start with 19. The following structures represent different types of soap. Alright, so now, which statement about soap is correct? Soap is, now look at what will happen here. Okay, so both here, what we are finding is they have this, so they've got an ester part, so the soap is an ester here, so soap is an ester, so the correct answer is answer choice B. Okay, so this is you can find this one on esterification. You can find this one. We go to question 20. What would be the structure of the polymer formed when the following monomers undergo polymerization? When these monomers undergo polymerization, so this is polymerization, when an acid and an alcohol, okay, the reaction of an acid and an alcohol, so which polymer is going to be formed? So which polymer is going to be formed? Right, so we have that and that. So let me see which polymer is going to be formed. So we have, okay, we have that, then we have that. So there we are going to have okay, so number 20, we're going to have answer choice D is correct. For on number 20, answer choice D is correct. So this is the part of organic chemistry. Now the only challenge is that in explaining some of these terms, I'll have to go back and explain some terms which are there, and it becomes a bit difficult. It might take a lot of time, but the correct answer is answer choice D for this one. Okay, so now let's look at a different question. We are done with section A. We are done with section A. We go to section B and see how best we can go about these questions. Section B1. The following experiment was set up to investigate factors that affect the rate of diffusion in gases. During the experiment, a cloud of white smoke was seen as the ammonia gas and hydrogen chloride gas reacted. So there was a reaction of ammonia and hydrogen chloride. So there is a tube T. We have cotton wool that is soaked in ammonia, and another one that is soaked in hydrochloric acid. So now, what are they trying to tell us? Define the term diffusion. So how can you define diffusion? We define diffusion as the movement of particles from a region of high concentration to a region of low concentration. Okay, why is that happening? That is happening so that particles, they become evenly distributed. So we are saying diffusion is a movement of particles from a region of high concentration to a region of lower concentration so that the particles become evenly distributed. So that's diffusion. Part B, which of the particles for ammonia or hydrochloric acid to move faster? So which of the particles for ammonia or hydrochloric acid to move faster? Now look at them. We have cotton wool that is soaked in ammonia and one that is soaked in hydrochloric acid. Now the question is that which of the particles will move faster? Those for ammonia or those for hydrochloric acid? Which one do you think are going to move faster? So the ones which are going to move faster are the ammonia particles. So the ones which are going to move faster are the ammonia gas particles. So ammonia gas particles. Now you know the movement of gases. So the ones which are going to move faster are the ammonia Okay, so the ammonia gas particles, those are the ones which are going to move faster, at which point A to D along the tube T with the white cloud be seen. So at which point A to D along the tube T will the white cloud be seen. Now let's go back. A to D. So let me read the question again. The following experiment was set up to investigate factors that affect the rate of diffusion in gases. During the experiment, a cloud of white smoke was seen as the ammonia gas and hydrogen chloride gas reacted. So now look at particles in ammonia gas are going to move at a faster rate, and they're going to be seen at the point somewhere at point C. So at point C, so on that question, which says at which point A to D along the tube T will the white cloud be seen. So the white cloud will be seen at C, then will be told to explain. Okay, so I can explain your answer in C1 in terms of movement of particles. Now, in terms of movement of particles, particles of hydrogen chloride, they move slower than the particles of ammonia. So, the particles of HCl are going to move slower than the particles of ammonia. Why? Because now if you consider the two, hydrogen chloride has got chlorine, and if you see the mass of chlorine in comparison with the mass of nitrogen, you are going to discover that chlorine has got a mass of 35.5, but nitrogen has got a mass of 14. So meaning the one that contains chlorine is going to move slower because of the mass of that. Yes, so that is basically it. State a factor that affects the rate of diffusion in the experiment above. So one factor that affects the rate of diffusion is the mass, just like I explained. So the molar mass. So the molecular mass. That is one factor that affects the rate of diffusion. Safety precaution you take when carrying out the experiment. Okay, so now since we are dealing with gases, so the safe precaution that one would take is by using what we call a fume hood. So by conducting the experiment in what we call a fume hood, one that is going to defend your body against fumes. So since those are gas particles, and so one that would defend your body against you. So a fume hood. So that is basically it. We proceed. We look at B2. Question B2. The following are some common substances. Choose from the above list a substance which is a compound containing three elements. A compound containing three elements. Now I'm sure you're already familiar with this. A compound that is containing three elements. Here it is our limestone. So a compound that is containing three elements, it is limestone. Alright. A substance which is a mixture of two elements. So a substance which is a mixture of only two elements, it is brass. So brass is a mixture of two elements. Okay, so I'm sure you are familiar with metals. Those who are familiar with metals will be able to answer these quickly. So we have brass, then a substance which is a mixture containing both elements and compounds. So the one that contains both elements and compounds is air. Air is a mixture of gases. And then one which is a mixture of compounds only. So one which is a mixture of compounds on that list is petroleum. So one which is a mixture of compounds is petroleum. Right. From there now we have question B3. Atoms of J and K have 8 and 12 electrons respectively. Determine the formulae of the compound / molecule formed by the combination of J and K. Alright, so now we have J and K, okay, which have 8 and 12 electrons respectively. So look at what is going to happen. So J, we have 2,6, then K, K has got 12 electrons, so it will be 2,8, 2, like that. So meaning J has got 6 electrons in the outermost shell, K has got 2 electrons in the outermost shell. This tells us to say J is a non-metal, whereas K is a metal. So this type of bonding that will take place is going to be ionic bonding, and K is going to donate 2 electrons. So K is going to donate 2 electrons. So they are saying determine the formula of the compound or molecule formed by the combination of J and K. So K is going to donate 2 electrons to J, so they will become stable. So they are going to form JK. So they are going to form JK. JK. Because only one atom of J and one atom of K, then you do the combination. But if J, okay, if you have to form J and J, meaning since J is a non-metal, so J and J, they are going to bond using covalent bonding. So we need 2 atoms of J, where 2, this would donate 2 electrons and another one will come and donate 2 electrons. So we need 2, so it will be J2. So in each case as shown, name the type of chemical bond formed. Now in the first one, since it was between a metal and a non-metal, so the type of bond that is between a metal and a non-metal, it is the ionic bonding. So in the first one, the type of bond that is there is called ionic bonding. In the second one, since it is between a non-metal, it is called covalent. So covalent bonding, the type of bond that takes place between non-metals. Okay, we have part C. Give 2 physical properties of the compound formed in A1. In A1, so properties of an ionic bond. So number 1 is that they've got a high melting and boiling point because of the strong ionic bond. So they've got what we call high MP and BP, high melting and boiling point. Then they are also soluble in water. So ionic compounds are soluble in water. Okay, so those are the 2 physical properties of the compound formed in A1. Okay, so we proceed. We look at B4. B4 is a question. What is the major characteristic feature of an acid? Now, the major characteristic feature of an acid, what helps us to know that this is an acid, is the production of hydrogen. The major characteristic feature is the production of hydrogen ions when dissolved in water. So, hydrogen ions. So, that is the major characteristic feature. Explain what is meant by each of the following terms. The first one, weak acid. How do we explain a weak acid? A weak acid is an acid that partially ionizes in solution. So a weak acid is an acid that partially ionizes in solution. So it partially ionizes in solution. Then a strong acid is an acid that completely So a strong acid is an acid that completely ionizes. So this one completely ionizes in solution. So it completely ionizes in solution. Okay, then we look at part C. Write equations to show the ionization of dilute sulfuric acid. Now sulfuric acid is like this, H2 SO4. Now if you ionize it, so meaning you dissolve it in water, so you put aqueous, it's going to form what we call hydrogen ions, aqueous, and it is going to form sulfate ions. So the valence, so sulfate has got a 2 minus aqueous. Then ethanoic acid is written like this, it's an organic acid, COOH. So when you ionize ethanoic acid, so this one does not ionize completely, so we use this. So it's going to form CH3 COO minus aqueous plus H plus. So ethanoic acid is a weak acid because it does not ionize completely. Only one hydrogen has been ionized. Okay, B5, excess zinc metal. So we are saying excess zinc metal was added to 200 cubic centimeters of 2 molar hydrochloric acid. Write a balanced chemical equation for the reaction. So zinc, now zinc is a solid, Zn, zinc is a solid. Then reacting with HCl, okay, this HCl aqueous, then this one is going to give zinc chloride, so that's zinc chloride, aqueous, then plus hydrogen gas, so what remains is just the issue of balancing. So chlorine, there are 2 atoms of chlorine, you just put a 2 here to balance for both chlorine and hydrogen. So that one has been balanced. Then you proceed to answer the other one. Calculate the number of moles of hydrogen gas produced in the reaction. Now the number of moles of hydrogen gas which are produced. Now let us look at the mole ratios. Let us look at the mole ratios that we have there. Now in order for us to find the number of moles of hydrogen gas, let's go back to the question. We see the other data they've given us. So they are saying alright, excess of zinc metal was added to that and that. So for hydrochloric acid, they've given us the volume and the concentration. So 200 cubic centimeters and 2 molar. Okay, so we come here and I say where there is hydrochloric acid, they've given us 200 cubic centimeters and they've given us 2 molar concentration. So you can find the number of moles. Number of moles is equal to concentration times volume. Concentration is 2 molar. Volume is 200. You divide by 1000 to change it to decimeters cubic. So you find that. So we're going to say 200 divided by 1000. Then we multiply by 2, we have 0.4, so 0.4 moles. So those are the number of moles for hydrochloric acid. Then the mole ratios between hydrochloric acid and hydrogen, the mole ratios we have 2 to 1, where we have 0.4 moles of HCl, then X moles of hydrogen, cross multiply, then 2x is equal to 0.4. Then we're going to divide by 2, that goes, x is equal to 0.4 divided by 2. So we'll get about 0.2, so we'll get 0.2. So 0.2 0.2 moles. So 0.2 moles of hydrogen. So we get 0.2 moles of hydrogen. So that was basically it. That was basically it. The other one, volume of hydrogen gas produced at RTP. So I'll start firstly, I'll say volume is given by number of moles. Now RTP simply means room temperature and pressure. So the volume of a gas at RTP is equal to 24 cubic decimeters. So volume of a gas at RTP is given by number of moles multiplied by 24 decimeters cubic. The number of moles that we found for hydrogen was 0.2 times 24. So 0.2 times 24, we get 4.8. So we get 4.8 decimeters cubic of hydrogen. So we have found the volume of hydrogen. Now that the volume has been found, we proceed to another question. What mass of zinc? All right, so I just go a little bit back. Okay, so we have a question there. We have found the volume. So the other question is asking us to find the mass of zinc which was used in the reaction. So what mass of zinc which was used in the reaction? So how do you find that? How can you find the mass of zinc? How can we find the mass of zinc? Okay, so mass, remember, mass is equal to, there's this formula, mass is equal to number of moles multiplied by molar mass. Now, the number of moles, so we're looking for the mass of zinc that was used in the reaction. So the number of moles between hydrogen and zinc, since the mole ratios are 1 to 1, so the number of moles will be the same. So the number of moles still remains 0.2. Then what is the molar mass of zinc? The molar mass of zinc is 65 on the periodic table. So when it says 0.2 times 65, we get 13 grams of zinc. So to get the mass, you just multiply the number of moles with the molar mass. Then you get the mass. Okay, we look at question B6. The following table shows elements coded with letters Q to Y which do not represent the actual symbol of any of the elements in the periodic table. You need to use these letters in some of your answers. Okay, which element shown, okay, forms ions with a single negative charge? So which element shown forms ions with a single negative charge? So the elements that forms ions with a single negative charge are found in group 7. So this is group 0, group 7 is here. So you can pick either W or X. All those are going to form ions with a single negative charge. Then group 7 has 3 electrons in its outermost shell. So the one that has got 3 electrons in its outermost shell should be found in group 1, should be found in group 3. So if the number of electrons in the outermost shell is equal to the group number, so the one which is in group 3 is a V. So our answer is V there. How many protons does an atom of element Y contain? Okay, so how many protons does an atom of element Y contain? So we go where Y is. Where is Y? So have you seen Y? Y is helium. How many? Y is helium, yes. Then Q is hydrogen by just looking at them. Hydrogen is independent, then it is in the same line. So they are the only elements which are in the first period, hydrogen and helium. So helium is like that. Helium is H4 and 2, so it has got 2 protons. So helium has got 2 protons. So the number of protons for helium are 2. Then state the element which is the most reactive metal and most reactive non-metal. So now we go back there. So which element is the most reactive metal and which element is the most reactive non-metal? So the most reactive metal is francium, the one which is just found down. Then the most reactive non-metal is fluorine, and fluorine is just found on top of group 7. So the one which is found, so we go to group 1, the one which is found furthest group 1. So reactivity increases as you go down the group for these. Then for these nonmetals in group 7, reactivity increases as you go up. So the one which is on top here is the most reactive nonmetal, W. Then T is the most reactive metal. So those are the answers we put. So on metal, we said T. On non-metal, we said W. Then we go to another question. Deduce the formula of the compound formed between elements U and W. So U and W. So we have U and we have W. So let us find their valences. Their valences, we look at where they are found, U and W. U is found in group 2. So the valence will be 2. What of W? W is found in group 7. It needs 1 electron to be stable. So the valence is 1. So U, the valence is 2. Then W, the valence is 1. So I come here. U, the valence is 2. W, the valence is 1. They swap and it becomes U1, W2, which is just the same as UW2. So UW2. So that is our answer for that one. We proceed to another question. Question B7. The following reaction scheme shows what occurs during the extraction of zinc metal from one of its ores, which is zinc blende. So that is what we have. Then we are saying deduce the chemical formula of zinc blende. Now zinc blende is just zinc sulfide. So it is ZNS, that is zinc blende. Name solid L and gas M. Solid L is here and gas M. So solid L, that's the zinc blende that we're talking about. So for L, we say zinc blende. So L is equal to zinc blende. But what of gas M? So the gas that is produced is carbon monoxide, CO. So when zinc, so solid L, then the gas that is produced is carbon monoxide. Carbon monoxide. Construct the chemical equation for the reaction of solid L with coke. So the reaction of solid L, we said, let's see, did I say zinc? No. You are roasting zinc blende in air. No, you are not getting zinc blende. You are getting, so solid L is not zinc blende, but it's zinc oxide. I made a mistake here. L is zinc oxide, not zinc blende. L is zinc oxide, because the zinc blende was the one which was being roasted in air to give, because the air has got oxygen, so to give zinc oxide. So now if we are to construct a chemical equation now, we're going to say the zinc oxide reacting with coke. Coke is carbon. then it is going, so what will happen is that it is going to form Zn plus CO. So meaning the zinc oxide will undergo a reduction, then carbon will undergo an oxidation. That is basically what happens there. Part D, sorry, I just go down a bit. Where are we? Okay, so I have to. Sulfur dioxide gas is a pollutant. Explain its effect on plants. So what are the effects of sulfur dioxide gas? So the effects are that it is going to form acid rain, and acid rain destroys crops. It slows down the growth of plants. So this sulfur dioxide, it is an acid. These are called greenhouse gases. So this sulfur dioxide is going to can dissolve in water to form sulfuric acid. So it forms acid rain. So this one forms acid rain, and now the acid rain now is the one that is going to destroy the crops now, and it's going to slow down the growth of plants. So that's basically what happens. Now question B8, the four hydrocarbons given are members of a homologous series. Explain the term hydrocarbon. Now by hydrocarbon, we are just looking at a binary compound that is containing carbon and hydrogen. Those are hydrocarbons. So hydrocarbon is a compound that contains hydrogen and carbon only. Those are hydrocarbons. Name the homologous series to which the above hydrocarbons belong. So now let us look at them. So look at, for instance, look at the first one. What is the name of the first one? The name of the first one, since it has one carbon, it is called methane. Methane. Now, since they end in ANE, the name of the homologue is called alkanes. So they fall under alkanes. Then compound with molecular formula C4. So an alkane with 4 carbons is called butane. So an alkane with 4 carbons is called butane. All right. Draw the full structure formula of the hydrocarbon which has 4 carbon atoms. So we need to draw the full one, which is butane. So we draw the full structure of butane. So we start 1, 2, 3, 4 carbons. Then you attach the hydrogens like that, the hydrogen like that, the hydrogen like that, hydrogen like that, hydrogen, 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 hydrogen. So now that is how we can go about that one. So that is how we can go about that one. Let us look at which of the given hydrocarbons has the highest boiling point. Now let's look at what we've been given. So the ones which are given, then we need to find out the one with the highest boiling point. So let's go back to where the hydrocarbons are. Where are they? Where are they? Where are they? So we go back to where the hydrocarbons are so that we'll be able to answer the question. All right, they are here. So now look at we have they are starting with methane and all the way up to decane, which is C10H22. So now the question is that which of the given hydrocarbons are the highest boiling point? Now boiling point increases with the increase in the number of carbons. So methane has got only 1 carbon, whereas decane has got 10 carbons. So the higher the number of carbons, the higher the boiling point. So here it is decane, C10H22. Decane is the one that has the highest boiling point. Proceed. We look at so the questions are done in section B. We go to section C and see what's there. Answer any two questions from this section in the separate answer booklet. The following scheme shows some reactions of a dilute acid A. Okay, so that is what we have. Then name and give the formulae of dilute acid A. Now look at dilute acid A. This is acid A. It has undergone a reaction and to produce sodium sulfate and water. Now this sulfate here is coming from the sulfuric acid. So the name of this acid is actually called sulfuric acid. And if it was called sodium chloride, then this acid would have been hydrochloric acid. Now since there is a sulfate, it's sulfuric acid. So the name is like that, sulfuric acid. Then the formula is H2SO4. That's the formula of sulfuric acid. Substances B and C. Okay, so we need to name and so substances B and C. So that is substance B. Then we have C here. So we are going to start with B. So where is the sodium coming from? So an acid is reacting with a base to give sodium sulfate is a salt and there is a water. So the sodium is coming from the base, which is sodium hydroxide. So B is sodium hydroxide. So it's a reaction between an acid and a base. How do you write sodium hydroxide? NaOH. That is sodium hydroxide. Then C. When an acid reacts with a metal, so sulfuric acid is reacting with magnesium, it's going to form what we call magnesium sulfate. So C becomes magnesium sulfate. So it forms magnesium sulfate. So how do you write magnesium sulfate? You say MgSO4. MgSO4. That is how we write magnesium sulfate. Then look at just go back to where the questions are. All right, so we are here of okay, construct a balanced chemical equation for the reaction between substance B and dilute acid A. So substance B, we said it's sodium hydroxide, then the acid is sulfuric acid. So the reaction between sulfuric acid and sodium hydroxide, that is a simple one. So sodium hydroxide is like that, then sulfuric acid is H2SO4. These are going to react to form what we call sodium sulfate. So sodium sulfate, and they are going to leave water, which is H2O. So this one is a liquid. Then what of the sodium sulfate? Sodium sulfate is actually in aqueous. What of the sulfuric acid and the sodium hydroxide? These are in aqueous. These are in aqueous. Then we just balance. So how are we going to balance that? To put a 2 in front of sodium hydroxide to balance the sodium. Then to balance the hydrogens there and oxygen, we have to put a 2 here. Then it is balanced. So an ionic equation for the reaction. So to write an ionic equation, we just split them. It's easier to write an ionic equation, we split them. For instance, I'll show you this. Sodium hydroxide ionizes. Sodium hydroxide ionizes to form sodium cations and hydroxide anions like that. Then sulfuric acid ionizes to form 2H plus SO4. Then this one is 2 minus. Then the sodium, okay, sorry, so in front of the sodium there was a 2 here and there was a 2 here that was used for balancing. Then sodium sulfate is going to form 2Na plus SO4 2 minus. Then the water will remain. Whenever you're writing ionic equation, only ionize the species which are in aqueous form. So here the sodium will go, the sodium will go, the sulfate will go, the sulfate will go. So the only things we're going to remain with, it is 2OH minus, then plus, so this one will be in aqueous, plus 2H plus, this one will also be in aqueous. This should give us water, so 2H2O, which is liquid. So that's an ionic equation. So you just ionize and you cancel out the spectator ions. State the type of reaction that occurs in B1. So the type of reaction where an acid reacts with a base to produce salt and water is called a neutralization reaction. So it is called a neutralization reaction. So that is the name of the reaction. Okay, let us look at question C2. Question C2, calcium hydroxide or slacked lime is an industrial alkali. An alkali is a base that is soluble. So it's a soluble base. Explain the meaning of the term alkali. So an alkali is a soluble base. So that's the definition of an alkali, a soluble base. Explain how calcium hydroxide is produced, starting with limestone. Okay, so what happens? So what happens basically is that limestone is heated to form calcium oxide, which is also called quicklime. Then water is added to the calcium oxide. So once water is added, then the calcium hydroxide will be produced. So the calcium hydroxide will be produced. We go to part B. Give two large-scale uses of calcium hydroxide. Any uses of calcium hydroxide? Number one, it is used in neutralizing acidic soils. Number two, it is used in bleaching powder. Used in neutralizing acidic soils and for bleaching powder. Part C, a weak solution of calcium hydroxide is called lime water, and it is used to test for carbon dioxide gas. Construct a chemical equation for the reaction, include state symbols. So we are saying a weak solution of calcium hydroxide is called lime water and it is used to test for calcium. So now calcium hydroxide is written like that. CaOH2, that's calcium hydroxide. So this one, it is used to test for carbon dioxide gas. So the chemical equation for the reaction is it is going to form what we call calcium carbonate and water. So the state symbols are calcium hydroxide is in aqueous, this is calcium. Then carbon dioxide, you know, is a gas. Calcium carbonate is a solid, water is a liquid. Those are the state symbols, and it is a self-balanced equation. Give the chemical name of the salt produced during the reaction. So the salt produced, now this salt which is produced, the name is called calcium carbonate. It's called calcium carbonate. Describe what is observed during the reaction. So during the reaction, you are going to observe a white precipitate. So a white precipitate, or basically what we used to say at grade 9 to say the lime water turns milky, but basically you just say a white precipitate or a white suspension. White precipitate or a white suspension. Alright, we go now to the last question, which is question C3. Propene is, okay, so we have that. Propene is one of the many important hydrocarbons obtained from crude oil. Like propane, it is made up of molecules which contain 3 carbon atoms. Draw a structural formula for propene. Now, it's easier to draw the formula of propene. So it's like this. It has got 3 carbons. Prop means 3 carbons. It has a double bond. So like that. So hydrogen here, hydrogen there, hydrogen there, then hydrogen there, then like that. I'm sure you are familiar with how to draw. There are formulas that we use in drawing organic molecules. Alkanes have got their own formula. Alkenes and alkynes. Right, how does propene differ from propane in terms of bonds? So now, in terms of bonds, propene has a double carbon-to-carbon bond, whereas propane has got a single carbon-to-carbon bond. So that's the difference. So you find that, let me show you. So on the second one, let me show you the difference. What I'm doing now is for propane. This is propane. This is propane. Propane has got all single bonds. So between the carbon to carbon, they are all single bonds. But propane has got at least a double bond. So that's a difference in terms of bonds. To which group of hydrocarbons does propane belong? So propane belongs to the group of hydrocarbons we call alkenes. So we call them alkenes. Give the molecular formula for propane and propene respectively. So the molecular formula for propane and propene, let me start with propane. Propane C3, meaning there are 3 carbons. Then hydrogens, you just count them 1, 2, 3, 4, 5, 6, 7, 8. So H8. Therefore, propane, again 3 carbons, but the number of hydrogens they have reduced, they are 6. So H6. Okay, we go to the other one. Explain why propene reacts immediately with bromine water, whereas propane does not. So the reason why propene reacts immediately is that propene has a double bond which is broken to form new bonds with bromine. So it reacts because of the double bond. So the double bond can break to form new bonds. So it can undergo addition reaction. Those double bonds can break. So we are saying this is because propene has a double bond which is broken to form new bonds with bromine. But propane doesn't have a double bond. Okay. Describe what would be observed during the reaction. So during the reaction of an alkene with bromine, the bromine water is decolorized. So whenever bromine is reacting with an alkane, the bromine water becomes decolorized. So it becomes decolorized. But see, propene is obtained by breaking down longer chains of hydrocarbons. What is this process called? So the process in which longer chains of hydrocarbons are broken down, it is called cracking. So we call it cracking. So just the same ordinary cracking, so we call it cracking. Propene is a monomer for making an important plastic. State the name of the polymer it forms. So the polymer that propene forms is called polypropene. So it is called polypropene. So that's the name of the polymer that propene is going to form. It's called polypropene. I guess that was the last question for this paper. So you can pass through the questions, and if you're going to find any difficulties, you can get in touch with me and I'll be there to help by explaining again in other concepts where you didn't understand. Thank you.